All right, going back to the very front end of the chapter. Let's set my timer here. All right, very first thing we did was we talked about graphing exponents. The way that we graphed exponents, where it was a variable in the exponents, is we just plugged in. Okay, so we did like, I said graph this, and I said graph 2 to the x power. I would just pick values for my x. Now at this point, you know, graphing is not a big part of this chapter. That was just to let you see how variables in the exponents somewhat graph. So if I come down here and I go, okay, I'm just going to pick some values for the x. If I pick 0, -1, +1, and 2, okay? And I go, to find my y value, I'm just going to plug in. So if I put 0 right there where the x is, what is my y equal to? 1. So I have 0, 1. So I'm going to put that right there on my graph. Okay, if I put my -1 where the x is, what is that equal to? 1/2. So at -1, my y value is 1/2. Okay, what about if I put a +1 there where the x is? What is that? 2. So at 1, my y is 2. All right, what if I put a 2 where the x is? What is my y value? 4. So I know that I am going to get closer and closer to that 0, but I'm never going to hit it. Because there's absolutely nothing that I can put up there that is going to give me a 0 as a result. There's also nothing I can put up there that's going to give me a negative as a result. Okay, so the whole first part was just working with exponents and graphing those exponents. This is when we went back and reviewed some of the stuff about when the base number is the same, you add exponents. So if I have like that, what is that equal to? X to the 9th. Okay, remember that. Versus if I have, that's what we were looking at, 9. If I have x to the 3rd raised to the 6th power, what is that equal to? X to the 18th. I think at this point, this has become very natural to you. You don't think about it, you just do it. We reviewed all that stuff. Remember, anything to the 0 power is equal to 1. Doesn't matter what it is. Remember when you divide, if I have x to the 4th over x to the 5th, what's my answer?
1 over x.
1 over x, okay? Because basically what we talked is really, if you will, you're going to subtract them, and it's x to the negative 1st power. Because I go 4 minus 5, that's -1. But I know if it has a negative, it means I take it to the bottom of where it is. It's at the top, so to get rid of that negative, I'm taking it to the bottom. The other way we did that is we said, just subtract the smaller number from the larger number and put it where the larger number is. Okay, both of those work. Then we began to do some that you solve by making the base number the same. Just like what we just did on those problems in that last section. What I'm going to do, if you go ahead and get out like piece of scrap paper or whatever, we're going to do a couple of these and make sure that you guys can do them. You can do them on the, well, I started to say on the back of your study guide, but the study guide is front and back, so that would kind of limit you a little bit. So okay, first I'm going to give you one where the base number is the same, and I just want you to simplify this. And I know you can do the normal one, so here's one with square roots. Let's see what you can do with that. And then I'm gonna put a couple more down here for you to work on. Oh, that's fine. Okay, so there's those 3 problems on the board, so let's see what we can do with those. These all come out of section 10.1. Yes, no, maybe. Did you get them all?
Yeah, I started to make that one like harder than I.
Yeah, some of these are just so easy, but you don't think in the right direction. Now, you could have done it with base of 3, and you could have converted both with a base of 3, but they both can have a base of 9, which would make it a little bit simpler. Okay, all right, we good on that? All right, so that is basically all of section 1. Then we got to section 10.2, and we started working with logarithms. So these were the ones that you took it from your logarithmic form and put it in exponential form, took it from exponential form and put it in logarithmic form. Now, these are the ones that you only have a logarithm on one side. That's your hint that you should do it this way. Okay, that you have the logarithm on just the one side of the problem. At first, we were just taking standard exponential form and we were putting it in logarithmic form. Okay, so like for instance, let's say I have 5 to the negative 2 power is equal to 1 over 25. And they tell me to write it in logarithmic form. Okay, so I come over here. What is my base of my log going to be? 5, because the base is the same on both. So I have a base of 5. What am I going to put next?
Raised to the 125th power.
Okay, my answer for my exponential is what's going to go right there. My exponent is going to be my answer for my logarithmic. So negative 2 is going to go right there. Okay, that's just rearranging it and putting it in logarithmic form. You're not solving anything, you're just changing the form. All right, I'm going to give you one to do. Okay, just jot down your answer. So I have 4 to the 3 over 2 is equal to 8. Okay, put it in logarithmic form. should be the log of base 4 of 8 is equal to 3 over 2.
I started trying to solve it even.
Yeah, see, there's nothing unknown here. All they're doing is asking you to convert from one to the other. And the instructions literally say, write each equation in logarithmic form. Then it's going to turn around and it's going to say, write each equation in exponential form. And it's going to give it to you here, and it wants you to work backwards. Okay? So just pay attention to the instructions. If it wants you to solve it, it's going to say solve. All right? So this one, let's say I have the log of base 8 of 2 equals 1/3. Write it over there in exponential form. Should be 8 to the 1/3 power equals 2. Which you know is true because the cube root of 8 is 2, and that's what it's saying. Okay, any problems on that? I mean, it's just a matter of converting it back and forth. All right, then you had things like this. It would say evaluate. So I might have something that looks like this. Evaluate means give me the answer for it, if you will. Now, if it helps you, when it does like this, if you want to, put an X there. Because that's what it's asking for. It's asking for the value based on the X. Now, you can do these a couple different ways. Because now we've learned a shortcut to do them. I can't unteach you the shortcut. So we can turn around and go, okay, if I have a log of base 10 of 10 to the 3rd power, and I want to know what that's equal to, I can write it and go, 10 to the x power is equal to 10 to the negative 3rd power. What is x equal to?
-3.
-3. Okay, that would not be what I would say would be the shortcut way to do it. Any idea what I would say is the shortcut way to do it? Remember how I told you that you can do division with the logarithms. Okay, so I can do the log of 10 to the negative 3rd power divided by the log of 10. Remember, the log of this divided by the log of that. Guess what that's going to give me? -3. Okay, so you can do it either way. I can't unteach you the shortcut. All right, and that gets even more extensive later on. Okay, what about this one? Give me an answer for that.
2.
It is 2, and you might be going, how in the world did he get that quick? Well, because he thought about it going the log of base 12 of 12 squared. And remember, if the base and this number matches up, the answer is the exponent. Because what you're saying is 12 to what power is going to give me this other number. So you're saying, okay, 12 to what power gives me 144? It would be 12 to the 2nd power, okay? But you can also do it the other way. You can take the log of 144 divided by the log of 12, and it's going to give you 2. Okay, it works either way. We learn the shortcut later on in the chapter. But like I said, once you learn a shortcut, you can't unlearn a shortcut. All right? I probably would have done it that way because I always err to the side of not using my calculator. And so if I could take it and not use my calculator and figure out how to do it, I would do it. Okay. Are we good on all that? All right, I'm going to give you, now these are some where you actually have to solve. And the way that you're going to solve it is either by making the logarithms the same and marking them out, or making it and changing it to exponential form. It totally depends on the problem. So you've got to make the decision. So I'm going to put a few up here that I want you to solve for. for those three. Do you have the answers up there, so check them when you finish. Yes, no, maybe? Vivian, which one are you struggling with?
Just double checking the last one.
Okay, what I did was I just marked out the log of
Yeah.
6 on both sides instead of equals
I
on
wrote
it.
it down wrong
Okay,
again.
it's just, for some reason, it's really not a natural process, but the more you do, the
I
more
keep
you do.
writing them down wrong.
Oh, okay, alright. Alright, let me show you one more, we're gonna do this one together, because this one's a little different. And then we'll move on to the next section. At first, it looks like, oh, well, this is really easy. And it is relatively easy. Oh, there's an X right there. And you know these things work the same with inequalities as well. Alright, so again, I have a log of base 2 that I'm going to mark out. So I have x squared plus 6x is equal to x minus 2. I'm going to bring the x over. So that's going to be a 5x. Hold on, let me restart this.